Now we'll take the detailed explanation about quadriphase shift key. That is how we have generated the QPSK signal. So as it is quadriphase shift key, it means that there are the difference between the carriers what we have used. The phase of the carriers is difference is pi by 2. Therefore, it is known as quadriphase shift key. That is the carrier difference between the phase of the carrier between the symbols is 90 degree. Therefore, the name given as quadriphase shift key. Now here, so as we have already seen the binary phase shift key, so which is using only the two symbols, that is either 0, either 1. So only 1 bit per symbol is transmitted. So how to utilize the bandwidth efficiently? So the quadriphase shift key is the method with which we can use or we can efficiently utilize the bandwidth. So how we are increasing the efficiently utilizing the bandwidth is we are transmitting 2 bits per symbol. So therefore if we are having 2 bits per symbol, then we are having 4 combinations, that is 4 symbols, that is S1, S2, S3, S4. So therefore we can transmit S1, either it can be 00, S2, 01, S3, 10 or S4, it can be 11. So in this way we are utilizing the bandwidth, and you can see that there are 4 symbols that are transmitted. That is 4 symbols, it means that 2 bits per symbol. Now here so symbols are carried. What we are doing here is symbols are carried by one of the phase of the carrier, which takes 4 equally spaced values. The phase of the carrier is varied by, that is pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. How it is generated? So already we know that how to generate a signal Si of t, that is whatever we are generating Si of t, it is represented in the form of linear combinations of orthonormal basis functions. This already we have discussed. Now similarly we are again generating in the similar way, that is we are using the orthonormal basis functions. Here we are using 2 orthonormal basis functions, that is phi 1 of t and phi 2 of t. Therefore the signal constellation is 2 dimensional, that is n is equal to 2. Therefore phi 1 of t is equal to root of 2 by t cos 2 pi fct, and phi 2 of t is root of 2 by t sin 2 pi fct. So these two signals, these two are orthonormal basis functions which are orthogonal to each other, because you can see sin 2 pi fct minus pi by 2 will become cos 2 pi fct. So therefore they are the orthonormal basis functions of unit energy. So when you take the energy of both, that is unit energy, they will be normalized to 1 unit energy. Now as we know this equation, Si of t is equal to Si1 phi 1 of t plus Si2 phi 2 of t. So this is a linear combination of orthonormal basis function, where I is equal to 1, 2, 3, 4. That is we are going to generate 4 signals, 4 symbols, therefore 4 signals has to be transmitted. Now how to represent that symbol? Now here we can see we are taking that where E is the signal energy per symbol. That is, if E is the signal energy per symbol, then what is the amplitude of the amplitude of the symbol? It is equal to root of E. Now if the symbol has 2 bits, then we have amplitude of each bit will be equal to root of E by 2. That is nothing but your amplitude of the each bit. So now here, so when you take this one S1 of t, here I1, Si2. That is, here Si1 and Si2 indicates what? It is nothing but the symbols. That is it may be here Si1 it may be 0 or 1. Si2 may be 0 or 1. So we can take it as 0 or 1. So 0 indicates minus of root E by 2, and 1 is indicated by plus of root E by 2. So it may be having a value of plus or minus E by 2. So we are using a polar non-return to 0 encoding scheme, line coding scheme for this purpose. So 0 is indicated by minus root E by 2 and 1 is indicated by plus E by 2. So when you just take it Si1, now here I am taking Si1 is equal to of quadriphase shift key, that is 2 bits are transmitted. Now here you can see when I am using 1 1, so if I am using the combination of 1 1, that is if I am transmitting a symbol, here a symbol is transmitted at a time, that is 1 1 combination. So 1 1 is transmitted. So 1 indicates root e by 2. So root e by 2. Another one indicates plus root e by 2. So what I have done is here root e by 2 as it is, that is SI1 root e by 2. Phi 1 of t is root of 2 by t cos 2 pi ft, and plus again this is plus. Then what is SI2? SI2 is also 1. 1 means what? Root of e by 2. So root of e by 2, root of 2 by t sin 2 pi ft. So this we have written with respect to this equation. Now when you just manipulate this equation, that is when you just change this equation, you will get it as, what I have done is I have taken root 2 e by 2 as it is and root 1 by root 2. So what is 1 by root 2? 1 by root 2 can be written as cos pi by 4. So I have written as cos pi by 4. Similarly here also I have done, that is 1 by root 2, I have just taken it as again sin pi by 4. So I have written sin pi by 4. So when you just look at this equation, so you can see I have taken, if I take this common, that is root of 2 e by t common in both the equations, that is in both the terms, then we can have this is cos a cos b plus sin a sin b. So cos a cos b plus sin a sin b is equal to cos of a minus b. So therefore I can write it as root of 2 e by t into cos of 2 pi ft minus pi by 4. So similarly, if so this is for the waveform 1, that is when you are transmitting 1 1, that is symbol 1 1 is transmitted. Now similarly you can just do it for when the next symbol is 1 0. 1 0 means just substitute here, 1 0 is root e by 2 and 0 means minus e by 2. When you just take it as minus e by 2, so you are going to get, so here I have just written here S21, that is plus and minus, it gets 1 0. So 1 0, if I am just doing it, I am going to get cos 2 pi ft plus pi by 4. Next, I have done it for third waveform, that is this one is indicating 1 0, symbol 1 0. Next is this one, that is 0 0, that is both are minus root e by 2 and minus root e by 2. So when it is 0 0, you are going to get cos 2 pi ft plus 3 pi by 4. Next again, you can see when I am taking it as it is 0 1. For 0 1 combination, 0 1 means what? You are going to substitute minus root e by t 2, and here 1 means plus e by 2 as it is. So when you just solve this equation for various combinations, for 1 1, for 1 0, for 0 1, for 0 0. So you are going to get 4 equations. So here I have just termed 4 equations, 1 2 3 4. So 4 equations are here. So when you just see here 4 equations, S3, so S1, S2, S3, S4. So you are going to get the equations as minus cos 2 pi ft minus pi by 4, cos 2 pi ft plus pi by 4, cos 2 pi ft plus 3 pi by 4, and cos 2 pi ft plus 5 pi by 4. So these are the equations what we are going to get here. So now when you just look at these equations and with respect to the signal diagram, when I am drawing here, so with respect to the signal diagram again I will draw. So that is, what is cos 2 pi ft minus pi by 4 indicates, it is nothing but, so this is cos 2 pi ft minus pi by 4. So this is indicating 1 1, symbol 1 1, that is message 1 1. Next is cos 2 pi ft plus pi by 4. Plus pi by 4 is here, that is plus pi by 4 indicates here. So what is this equal, so it belongs to which one? So it belongs to 1 0. So next is cos 2 pi ft plus 3 pi by 4. So plus 3 pi by 4 indicates what? So plus 3 pi by 4 comes where? So it comes here, that is plus, so here it is plus pi by 4, that is pi by 2 plus, so here it will indicate, so here this one I have done it for 0 0, so 0 0. Okay, next is last one, that is 0 1. For 0 1 it is plus pi by 4. So it is here, from here if I take plus pi by 4, this is plus 3 pi by 4, then again if I take this is pi plus, okay, pi plus pi by 4, it will give you 5 pi by 4. So this one will be your 5 pi by 4, which is indicating your 0, 1. So these are the 4 signals, signal constellation diagram. So if I take with respect to the, if I take the counterclockwise direction, so always, so this is with respect to, this is plus pi by 4. So this is what? This is minus pi by 4, plus pi by 4, 3 pi by 4, 5 pi by 4. So when I take in this direction, that is, here it will be, so this M1 will be, so this is pi by 4. So from here to here, it will be 3 pi by 4. Then from here to here, it will be 5 pi by 4. And last one, from here to here, it will be 7 pi by 4. So the phase shift. So how much the phase shift? So phase shift between in the carriers. So when it is 1 1, here I have just written. When it is 1 1, it is 5 by 4. When it is 1 0, so here it is 1 0. 1 0 it is 7 pi by 4. You can just get this equation. That is, if it is pi by 4, you just subtract 2 pi. 2 pi minus pi by 4 will give you 7 pi by 4. Again here 2 pi minus 3 pi by 4 will give you 5 pi by 4. That is when you have the symbol as 0 0. So that is 0 0 indicates it is 5 pi by 4. It is 5 pi by 4. The carrier is having a phase shift of 5 pi by 4. Last one is 0 1. So it is 0 1 is here. So 0 1 is having a phase shift of 3 pi by 4. So in this way we are going to generate the 4 signals. 4 signals of different phase. The phase of the carrier is different for 4 signals. One interesting concept here is, so you can see here 1, 2, 3, 4. So all the 4 signals are obtained by, they are having a phase difference of pi by 2. Therefore the name given as quadriphase. That is, if you just take here cos 2 pi is minus pi by 4. So minus what is the phase here? Pi by 4. So pi by 4, again when you just add plus pi by 2. So you are going to get again pi by 4. So this you are going to get. Next pi by 4 plus pi by 2. You are going to get 3 pi by 4. 3 pi by 4 plus pi by 2. You are going to get 5 pi by 4. So in this way the phase difference between, that is in the signal 1, 2, 3 and 4. So there is a phase difference of pi by 2 between this and this. Phase difference of pi by 2 between this and this. And phase difference between pi by 2 and this and this. And there is a phase difference of pi by 2 between 4th and 1st. So in this manner, there is a phase difference of pi by 2 between all the 4 signals. Therefore, the name given as quadriphase shift key. So we'll continue again with the generation and detection of the signals. Thank you.